Hey everyone. So we are going to start from the Leetcode Speedrun session. This is day one, and the topic for day one is Maths Easy. So as you can see, these are the questions which are given over during day one. Uh, these are a lot of questions. So if time permits, then I'll try to solve all the questions. If not, I'll just try to solve partial of the questions if possible, and then upload them next day or maybe day after tomorrow, something like that. So these are the questions that we have planned to solve. And without further ado, we'll just try to solve the first question. So the first question is number of good pairs. And given an array of integer nums, we need to just return the number of good pairs. And the good pairs defined as a pair is called good if nums I equal to nums j and I is less than j. So there is an identical element, that means this condition holds that if there's an identical element and if there's a particular index which is let's just say j, which is greater than I, then we can call it a good pair. So if you could just to think of a brute force solution, major brute force solution would be traverse to all of the paths which are possible, all the pairs. For suppose let's just say we fix our I at 1, we try to iterate through all the other remaining elements, and we try to see if the index has the similar element as the I element, ith element, and we try to generate all these combinations. So that's a two-port solution which will give us an order of n square solution. But since the O(n) square solution is not good, we just need to try to solve it in O(n). And yeah, we could do it in O(n) if we could just keep a track of the number of elements that have already occurred. And using that way, we could just use a hashing data structure. So right now, I could just think of a hash map, which is a map. I have the key as integer, the value is also as integer. You could just call it a map, and we are declaring an answer is equal to 0. So apart from that, we just need to iterate over that particular array. So I can iterate it using nums, using for each loop. So what can I do? I just simply say so. Is a current array which is given as 1, 2, 3, and 1, 1, 2, 3, 1, 1. So suppose if we encounter a first element which is not there present in the map. So currently our map is empty. So anything, if the key is null, so it will provide a value which is a null value, or if it is an integer, then it will be 0. So once we try to insert it, our value will have variable as key as 1 and value is 1 corresponding to that. So when we try to encounter 1 over the further iterations, we tend to feel that, yeah, we could, this is a good pair and this is a good pair, so we could just make one good pair out of it. So this is 1, answer would be equal to 1. Now when we encounter the second one, that means it has two options of making a good pair. Either it can have this element as a good pair, or it would have this combination as a good pair element. Hence it gives us an option of twice. That means there are two options for this particular integer. So if there would have been a third integer having the same value as 1, so let's just say call it here. So for this particular element, it could take this particular element at I, this as I, and this as I, and this one as j. So it has three options. So we could just see a pattern that the number of elements which are already present in the map, they should be added to each and every iteration. So yes, that's what we are actually looking for, and that's what the question asks us to do that. So what we'll do, we'll just try to mp answer plus equals to mp nums, and then we'll try to just we just I plus plus. This should be I not. And I think this would work. This would be working. This would be a feasible solution. So for now, let's just try to submit. Yeah, so it's get submitted, and this was the particular solution that this question was particularly asking for. We move on to the next question, that is subtract the product and sum of digits of an integer. So yeah, given an integer number n, we return the difference between the product of its digits and the sum of its digits. Now, what can we think of is that the question asks you to try iterate over that particular integer, go through its digits, and maintain two integers. One keeps track of the product of that particular digit, and the second is the sum. And then we try to return the difference. So, and if you try to think of brute force complexity or the time complexity, as you say. So, if it is a 32-bit integer, then we can call it that it's an oath of 32 or O of log n. If log base 2n. So, if assuming the integer is 32-bit integer, then just take order of 32. Otherwise, uh, yeah, so the time complexity can be, we call it in O1, space complexity is O1. I just forgot to mention what the space complexity in the previous question that we did. So since we were using map, the space complexity is also order of 10. So yeah, for this particular question, the time and space complexity will both be order of 1. Let's try to do it. So we are maintaining one product. We are trying to maintain sum, and sum has 0, product has 1. So why are we doing that? Because if we try to multiply a digit through this, we can simply call it, we can simply multiply it if we have 1. If we have 0, then we are not able to get a product. So here it is given that the constraints, the n ranges from 1 to 10 is 5. If the value of n would have been 0, then we would have another condition before doing the actual operations, maintaining an edge case for n is equal to 0. So for this particular case, I think we can have a simple while loop while n greater than 0, or simply n. Same thing in digit, we try to extract the digit and we multiply it to the digit prod variable and add it to this digit variable, that is the sum variable. And then we try to divide it by 10 and move on till the while loop, the while condition is right, result into false. That will happen when once n becomes 0, means we have reached the number of digits that we would have, and then simply we could just return the prod minus sum. Yeah, I think this would work. And if we try to solve using submitted, then it's giving 3 milliseconds faster than 7.47% of C++ solutions. If I try to submit it again, then these parameters would really change. So uh, best thing is not to focus about these particular parameters because they just provide a lot of variation, and these really aren't the actual parameters. So you need not to care much about these parameters, and these are very ranging on various factors on your net connection or your RAM speed or the memory which is available. So yeah, and so we move to the next question, that is number of steps to reduce a number to 0. Here we are given an integer num. It returns the number of steps to reduce it to 0. In one step, if the current number is even, you have to divide it by 2, otherwise you have to subtract 1 from it. As you can see, I've already done this question. So the question asks us to do the following operations. If we have a num as even, then we need to divide it by 2 and if the number is odd, then we need to subtract one from it. So if you just think in such pattern, and so we're given a number, right? And if there's an even, then we have to do something. If there's an odd, then we need to do something. If the number is even, I think what should be done, then we divide it by 2, else we subtract it one and do the same thing. And this is one operation, like this cost is one operation and this is one operation, right? The question asks us to calculate the total number of operations required to reduce it to 0. Okay, that's fine. So what can we think of is that if the number is even, then we do this particular operation, that is division, and we call it for the remaining particular integer that is left. And if the number is odd, we do the same thing. So if you could just say that we could have a recursive call, or we could have a recursive type of function which could possibly do these things. Could return 1 plus num, the name of the function. The name of the function is steps. Try to put it over here. We call it, this one is for the number, that particular operation that we have done. It might be division, it might be subtraction, and then we call it for the rest of our function, or for the rest of our iteration, that is number of steps. Nums divided by 2 will be called when the num is not odd. So here I check it, and we try to have ternary operator. This is a ternary operator, as you can see. If num modulo 2, that means if the number is odd, then we have to do -1. Else, we could just think of, we could just do number of steps, and then you can call it for num divided by 2. I think this would work since the constraints are ranging from 0 to 10 raised to power 6. Let's just assume what happens for 0. So for 0, return 1 plus 1. So if the number is 0, that means the required answer would be 0. And that would be the base condition for that as well. If num equals 0, then try to return 0. And number is 1, then we can just simply call it like, yeah, it's working fine. So num equals 0, we call this, otherwise we need to do this recursive call. This seems an error. Okay, so bracket, I guess. Bracket. Yeah, I think this will work now. For 40, it's fine. Try for, yeah, so it's getting submitted. So I think the solution is fine and clear. And now we can move on to the next solution. Next question. Next question is XOR operation in array. So given an integer and an integer start, define an array nums I equals to start plus 2 star I. It is zeroing next, and n equals to nums dot length, and we need to return the bitwise XOR of all the elements that particular nums array, right? So we are given an input as n is equal to 5, and we give start is equal to 0, and then we are trying to do start plus your nums I equals to start plus 2 cross I. So we are given a formula, and we need to generate over this array. So we try to generate this array, and we try to do as bitwise XOR for all the elements. So if we try to return the bitwise XOR, that means we'll have to return 0, XOR 2, XOR 4, XOR 6, or 8, and that would lead us to the answer as 8. Okay, fine. That seems a good question. So one of the major, the major solutions that we can think of in our minds is we could just generate an array using this particular formula that is given here, and we try to have a bitwise XOR. So if we try to think of the time complexity, then I would say the time complexity would be order of n, and the space complexity would be the order of n as well, since we are generating that particular array. Now, what if we don't want to generate the array and we try to solve this using just a single technique of not generating the array? So we could do that. We could just simply do it using maintaining a variable that is, uh, let's just say, this is the answer variable, which will be returning the answer, and we could just iterate it. Just iterate it for that particular loop. So I is equal to 0, I less than n, I plus plus, or let me just make it I is equal to 1, I less than n, I plus plus. And then the simple case like answer is equal to start. We can just declare start instead of 0, and we just XOR equals to start plus 2 and start plus uh, start plus 2, and then we could just increment our start plus equal to 2, and then uh, this would be updating our start and leading to a new value of that. Okay, so it's providing an error. Let me see happening. So start plus 2 cross I. Okay, so the first one, it shouldn't be, yeah, so I could just do 0, and then I less than n, and cross I, and this thing isn't required anymore. You could just do it simply like this. Answer XOR equals to start plus 2i. Here we can just simply call it 0. If you're declaring 0, then this particular function is already taking care of all the values that are being generated. So we need not to do any other modifications. Let's see if it is submit. Yeah, it's getting the same uh, expectation that we got. Yeah, we can move on to the next question. The next question consists of count of matches in tournament, given integer n, the number of teams in a tournament that has strange rules. If the current of teams is even, each team gets paired with another team, and then a total of n by 2 matches are played, and n by 2 teams advance to the next round. If the current number of teams is odd, then one team randomly advances to the tournament, and the rest gets paired, and the total of n minus 1 divided by 2 matches are played. Okay, so return the number of matches played in the tournament until a winner is decided. So when will the winner be decided? If we have n as 1, if there is a single team remaining, then we could just barely make out that, yeah, there is no other team apart from team number 1, and we could just call it that this is the winner team, and we need not have any other matches. So when n equals to 1, we can just say that we don't need any more matches, and we need to just calculate the number of matches. So there goes our base condition that once our n becomes 1, we need to return 0. Otherwise, we could just think of a recursive call the same way that we applied in the previous question, where we need to reduce the number of steps to 0. We could just return a function. So we need to return something when it is even and something when it is odd. So let's just say, for we take an example of 14, we can say that, okay, we can have 7 matches, so 7 teams advance to the round, and the number of matches is 7. And after that, this gets added. This is the number of matches track, and there are 7 teams. Now there are 7 teams, so that means now we need to have one team automatically advances, and then we have 3 more matches for the rest of the 6. So one team gets advanced, and there are 3 more matches. So that means 1 plus 3 equals the number of teams that are remaining are 4, and the number of matches which were held were only 3, because one team got selected just randomly, and the remaining teams were 6, and then 3 matches had to be occurred for these 6 teams. Now we have 4 teams remaining. For 4 teams, we have 2 matches, and 2 teams advance, and then for 2, we could have simply have 1, and one could simply just uh, we could just have one match between that particular team, that is the final match, and then we have a winner. When it goes to 1, then of course no other team members remain apart from team number 1, and then it should return 0. So if we just try to sum all these 7, 3, 2, 1, we could just simply say that the number of matches that happened for n is equal to 7 were, like, for n is equal to 7 was 6, for n is equal to 14 I could say is 13. N is equal to 14 I could say 7 plus 3 plus 2 plus 1. So here, as you can see, we have output as 13. If we need to apply for n is equal to 7, then n is equal to 7, it would be only this particular sum of numbers, that is 3 plus 2 plus 1, that equals to 6. So yeah, we could just think of a recursive function that keeps a track of the number of matches, as well as the recursive call that need to be done for the rest of the remaining value of n. So what we can do is just, we could have an if condition that tells us whether we need to divide the teams into equal number of matches. And so we have 2 cases, one for the even case and one that is odd case. So if we have even case, then n modulo 2 equal to 0. That means the number is even. We need to do something over here, and uh, we'll have we'll have something else. Yeah, so we could just have a different type of remaining sums for this. So if suppose, let's just say, if n is even, we need to return something. If if n is odd, that means the if condition handles the even case. We could just simply do return. So we need to return something in both of these written statements. So what we have to do, if the number is even, that means we have to return that particular n by 2 matches, plus we'll be calling the same function, that is the number of matches, for the further calls. And for how many number of teams? Now since n by 2 teams qualify, so we will call it for n by 2 teams. For this case, we'll have 1 plus n minus 1 by 2 teams will qualify, n minus 1 by 2 teams will qualify. So this will be providing the number of matches that has occurred till now, and we'll call it for the remaining leftover teams. That is a total of n minus 1 by 2 matches are played, and these many teams advance to the next round. These are the number of matches that have happened, and 1 plus n minus 1 by 2 will be the number of teams which advance to the next round. And I think this would be fine. Yeah, for 7, just as we expected. And yeah, works fine for all the test cases. Get submitted. Now we'll move on to the next question, that is the sum of odd length subarrays.